Algebra 2, 11.3, we're looking at combinations and permutations, and we're counting the number of possible ways to accomplish a certain task. Permutations are used when order is important, when order is relevant, when order matters. So if you're arranging people in line, being first in line is very different than being last in the line. First place versus second place. First place is much different than taking second place. Letters and codes, if you're writing out serial numbers and so forth. The order matters, like the word TAR is different than RAT. But sometimes you're going to find that order is not important. Combinations is what you use in that regard. If you were picking the number of people on a committee, either you're on the committee or you are not. If you are just naming starters for a basketball game, not what positions they're playing, but just being a starter versus not starting. Either you start or you don't. Order doesn't matter. So let's look at example 1. This right here means that order matters. This is a permutation. Order is relevant, you could even say. That's what they write on the Alex homework. So 4 items arranging 2, but order matters. Take a look at the letters A, B, C, and D. You could have 2 letters at a time. You could have AB, you could have AC, you could have AD. A comes first in all of those. Take a look at B. You could have BA. Very different than AB. It's almost like having first place and second place. Reading a word like ab versus ba is very different. You could also have BC or BD. You could have CA, CB, or CD. And finally, you could have DA, DB, or DC. This would be a listing of every possible way you could have 2 letters where order matters. You can see we have a 3x4 kind of a grid, 3 in a group, and you've got 4 groups, so 4 times 3 would be 12. Can we do this on the calculator? Yes. In fact, that's super important. We want to walk you through it. Always start with the big number first. That's 4. Go to Math, left arrow over here to PRB, then you go to NPR, and you hit a 2, 4 NPR 2. Hey, we get 12 just like you would have counted right above. But what if order didn't matter? 4 choose 2 where it's any order. So if we were to list 2 letters at a time where the order didn't matter, you could have AB, you could have AC, you could have AD. Now, I'm not going to list BA as being separate because order really doesn't matter. I already have BA right here, but I could have BC and BD. Likewise, I could have a C and a D. I wouldn't have a C and a B because I already have that right here. I wouldn't have a C and an A. I've got that over there. Looks like we've got 6 different ways we could list these. How could we get help on the calculator? Well, this time we're going to do a combination. This is where order doesn't matter. So I'll go 4, Math, go to probability, but go NCR. So 4 NCR 2, you can see just like we counted up above, if order doesn't matter, any order is fine for those 2. You'd have 6 different groups that you could come up with. Well, let's take a look at example 3. Suppose we want 2 colors without replacement taken from 3 colors of red, blue, and green. So we've got 3. For A, they're saying how many ways can this be done if order is taken into consideration? Order matters. Order is relevant. So that's going to be the P. We're going to say we've got 3. You always take big number first. You're going to say from 3, let's choose 2. So what will that look like? Well, we'll go 3, Math, come over here, bring down our NPR, and we'll get a 2. That's going to be 6. So we've got 6 different ways that can happen. What if order is not taken into consideration? In other words, order doesn't matter in B. You don't care what comes first. You don't have any concern about that. Whether it's red and blue or blue and red, it's all the same. Well, this time, if order doesn't matter, it's going to be a combination. And very quickly, you'll say 3, math. Bring this down here, and you'll say choose 2. And you can see there would be 3 different ways that could happen. Well, let's take a look. Honestly, the most important skill we can have is just determining whether order matters or not. So we've got 50 customers in a store collection. 3 are to be chosen to receive a special gift. How many groups of 3 are possible? Well, you're going to have 3 to be chosen to receive a gift. It doesn't matter who's named first, second, or third. They're all going to get that gift. In other words, order doesn't matter. Order isn't relevant, we could say. So it'll be 50 with a combination of 3 taken at a time. So let's see if we can work that out real quickly. 50, math, and we'll bring down our NCR, choose a 3, and a rather large number, 19,600. And there you have it. That's the number of groups that can be chosen. 3 different people in each group, but order does not matter. We've got 50 athletes running a race in B. Now we've got a gold medal, a silver medal, and a bronze medal. We've got 3 medals to be distributed. In how many different ways can the 3 medals be distributed? Order matters. Whoever is read first would be considered getting the gold medal. If that same person was, given a 3rd position or was read off 3rd, that would be a bronze. So order matters. This is a permutation. So it's 50 with a permutation, we're going to choose 3. So it's virtually the same looking problem, but very drastically different answer you're going to see. Because when order matters, you can have way more groups. You can see, indeed you do, 117,600. Okay, quite a few more. All right, take a look at this next one here, a committee. A committee consisting of 3 faculty members and 4 students is formed. Every committee position has the same duties and voting rights. Either you're in the committee or you're not. And I guess what I first want to point out is you need 3 faculty members on it, but there are 8 people to select from. Likewise with the students, you're going to need 4 students. But there are 13 students who are eligible to be selected, 13 that you can choose from. Well, the question is, does order matter? And the answer is, if it's just the same voting right and so forth, no, it's going to be a combination. So it's always big number first, and out of these 8 teachers or 8 faculty members, we're going to select 3. For a student, well, again, we're going to say out of 13 students, we're going to select 4. Order doesn't matter. But we've been seeing all this week that the fundamental counting principle is at play here. If you have so many ways to select the faculty and so many ways to select the students, you're going to multiply those 2 together. So let's do this real quickly. We can say 8 and select a combination with 3. That's your teachers. Then we'll say 13, and we're going to select 4 right here. And we're getting 40,040, 40040. Okay, so definitely wanted to also point out this is where our notes ended, but I was talking to some teachers and they were really wishing that we had a couple more examples because the last question that you're going to see gets to be a little trickier on the homework. So we've got a catering service for 11 appetizers. You have a choice, 5 main courses and 9 desserts. A customer is going to select 9 appetizers. Now, guys, as you're selecting 9 appetizers, please understand, as you're ordering that, the same appetizers are going to get wind up being put out or being put into a bag if you're buying them. Order really doesn't matter. If you were ordering some chips and then like onion rings and some other things to go with it, as long as you've got those 9 items, it's not like you're getting any benefit from having it read off first or second or third. It's one of the things you've selected or not. So that's a combination. Order doesn't matter. And it doesn't matter for any of these selections, really. If you've got 5 main courses, you want to select 4, 9 desserts, and you choose 2. Here's what's going on. You've got your appetizers, right? You've got 11, but you're going to choose 9 of them. You've got your main courses. You've got 5 of them, but you're going to select 4. And then you've got your dessert. And you've got 9 possible choices, but you're going to select 2 of them. Guys, as you work this out, you can just see 11. And we can get our combination here. So that's 11 choose 9 times 5. And then we can say, well, we're going to have 5 choose 4. And then finally, we'll say out of these 9, we're going to select 2. So you can see all of those get multiplied together. We'll have a big number, 9,900 different choices you could make. One final one. 3 research departments have 6, 8, and 10 members, respectively. Each department is to select a delegate and an alternate. So these are different duties, and in that regard, order matters. It's kind of like a president and a vice president. And how many ways can this be done? Well, order matters. So here's your first department. Out of 6 people, you need to choose 2. Your second department, out of 8 people, you need to select 2. And then finally, in that last department, you'll say out of 10 people, you're going to need to select 2. So here's where we're going with this. Nice and simple. We'll just get this worked out. We'll go 6. You can see a lot of using your calculator today, right? You have 6 NPR2 times 8 NPR2. Finally, we'll have 10 NPR2. And we get 151,200. And that would be the total number of ways that could be done.